Okay, for question number 34, part A, we have to prove that if a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, we have to prove that other two sides are divided in the same ratio, which is the BPT theorem. So let's try to prove that, and let's get our triangle first. So let's say this is triangle ABC, and in this triangle is given that line is drawn parallel to one side of the triangle, so let this be the line drawn parallel to one side of the triangle to intersect the other two sides in distinct points. Okay, let's label them. So let's say this is triangle A, B, and C, and this is line D. Okay, so what is given to us is that DE is parallel to BC, and we have to prove that AD by DB is equal to AE by EC. And for this, we are going to do some construction. We are going to draw perpendicular from D to AC and from E to AB. And we are going to join DC and we are going to join B. So this is DM and this is EN. So the construction I have done here is draw DM perpendicular to AC and EN perpendicular to AB. Now let's start with the proof. So in the proof, we are going to divide the area of triangle ADE by area of triangle BDE. Now area of triangle AD is half into base is AD. So this is the base AD. So this is AD and height is to the base AD, the corresponding height is EN. So this is EN. And for triangle BDE, it's the base is BD and this is an obtuse angle triangle. So this is how the BD is, which is obtuse angle triangle. So it's the perpendicular is, if drawn from this vertex, looks like this. So this is the perpendicular which is EN. So this is EN. This is BD. So the perpendicular is outside the triangle. So this half and half and EN gets cancelled. And finally we have AD by BD. Let's say this is the first set of equation. And once again, we are going to take the next triangle. This is same triangle ADE, but in this case on area of triangle DEC. Now ADE in this case, let's say the base is AE and corresponding to base AE, the altitude is DL. So now this is half into triangle DC is and also an obtuse angle triangle for which the perpendicular is outside the triangle, which is DM, and its base is EC and the perpendicular is DM. So this gets cancelled half and half. And finally, we have AE by EC. Okay, now this the triangle BDE and triangle DEC. These are between the same parallels DE and BC and on the same base DE. And we know that triangles on the same base and between the same parallels are equal in area. So here, area of triangle BDE is equal to area of triangle DEC. The reason being, these are the triangles on same base DE, and between the same parallels DE and BC, and triangles on the same base and between the same parallels are equal in area. And so that means I can replace DEC with BDE, and then both these two sides of these two equations becomes equal. That is, the LHS becomes equal and RHS becomes equal. So instead of replacing this, I can simply write from 1, 2, and 3. This is AD by DB. This is AD by DE. DB is equal to AE by EC. Hence, we have proved the PPT theorem. Let's move on to part B.